It's not.
It's not.
Okay, just started.
Okay. Let's go.
Okay. So imagine if a few data points could help predict whether a breast cancer patient survives. That's the future machine learning is pushing us towards. And today, I would walk you through how our project contributes to that future. Good morning, everyone. My name is Rebecca, and today we will present our project titled Prediction and Classification of Breast Cancer Survival using Machine Learning Models. My team members are Lawrence and Nikita. This project explores how data mining and predictive analytics can support survival predictions and inform better clinical decision. 2. So our project followed a full data mining workflow, starting with exploration, cleaning, visualization, analysis, transformation, and finally, building predictive models. The goal was simple: understand which features influence survival and test models that can make accurate predictions. This structure helped us move from raw data to meaningful insight. 3. 3. So we began by exploring the data set in detail. We checked the shape of the data, looked at each feature type, and identified missing variables and duplicates. No, Nikita. We also reviewed basic descriptive analysis, like the mean, the median, and the standard deviation, to understand how the data behaved. This gave us a solid foundation before modeling. So here we have the 4024 observation. We have the mean, median, and the standard deviation. This slide shows a detailed statistical breakdown of the data set. Here we have about 4,024 complete patient records across all the major clinical variables. These figures are important, so let me highlight the key ones. So the average age is about 54 years with a ranging from 30 to 69. The tumor size has a mean of 30 millimeter, but goes up to 140 millimeter, which tells us that the data set contains both early stage and very advanced cases. The survival time here has a median of 73 months, with some patients surviving up to 107 months, nearly 9 years. The next. So to make sure the data was stable, we performed outlier detection using the IQR method. We focused on key numeric features such as the tumor size, the patient age, the survival months. Removing outliers helped reduce noise and improved the overall accuracy of our models. 6. Okay. Next, we visualized the data to understand patterns. We created histograms to observe the distribution of numeric variables, a scattered plot to examine the relationship between tumor size and survival months, and a correlation heat map to see which features were not closely related. These visuals helped us identify trends that weren't obvious from the raw numbers alone. Next. Because machine learning models work best with numeric input, we transformed all categorical variables, the binary fields like alive stroke dead, positive stroke negative were encoded, and nominal fields such as age, grade, and stage were one-hot encoded. So by the end of this step, we had a fully numeric data set ready for modeling. Thank you. Lawrence.
The next slide is for data transformation. Before we could use our data for machine learning, we had to convert all our text-based data into numbers. Like for columns that have only two options, like alive and dead, and positive and negative, we could use binary coding, like alive for 1, dead for 0, positive for 1, and negative for 0. Then we used hot encoding for on the whole data set, meaning we created a new column for each category like T stage, T2, T3, and T4, and same for marital status, married, separated, and single. After applying binary and a one hot encoding on the whole data set, that made the whole data set all numeric. Next slide is for logistic regression. We have split our data into 80 and 20, meaning 80 for training and 20 for testing. And then we applied standard scalar on the whole data set just to normalize the data. Finally, we evaluated model using confusion matrix to see true positive, false negative, false positive, and a true negative, and a classification report, which is right here, to get metrics like precision, recall, FMO score, support. And this is our data we got for 0 and 1 under these metrics. And the accuracy rate we got is 0.89%. Next slide is for decision tree classifications. We have 3 diagrams up right here. The first one is confusion matrix for decision tree classification, which is also showing true positive, false negative, and false positive and true negative in a detailed report of it. And the second one is a ROC curve, which is giving AUC value, which is that 0.52. Finally, we evaluated the model using class. Finally, we evaluated the model using confusion matrix to see true positive and false negative, and true negative, and a classification report to get metrics. I think I messed up. Oh. We use process called grid search CV to tune the model, and we used 5-fold stratified k-fold. Since decision tree cannot be large, so we truncated the tree visualization. It shows most important nodes and splits on right here. The next slide is cumulative lift chart classification. Lift chart shows how well the model ranks the positive cases. We divided the data into 10 equal groups from the lowest to highest, a predicted probability. For each decile, like 0 to 2 is a one decile, 2 to 4 is a second decile, and so on. For each decile, we check how many true positive the model captured in that group. It shows number of true positive as we move lowest to the lowest probability decile up to the highest probability decile.
So with the decision tree regression, at this point in our project, we shifted from classification to predicting a continuous outcome, which is the number of survivors. So for this purpose, we use a decision tree regression model. This model takes the same clinical features from our data sets, such as tumor size, stage, age, lump node status, and tries to estimate how long a patient is likely to survive. We evaluated the model using the standard regression matrices, such as the mean square error, the mean absolute error, and the MP. Also, to ensure reliability, we applied 5-fold cross-validation, which helped us measure how stable the model predictions were across different subsets of the data. This regression model gave us a more detailed perspective on survival patterns beyond just alive or dead outcomes. Next. So for the regression results, Here are the results generated from our regression model. One of the most important of our evaluation was analyzing the DCY's average actual survival months. This means we grouped predictions into 10 equal path DCYs and then looked at how many months patients actually survived in each group. For example, in the top two DCYs, the average survival months were 70 to 30 months. Lower DCYs showed progressively shorter survival months. Also, this tells us that the model is good at ranking patients from lower expected survival to higher expected survival, even if predicting the exact number of months remains challenging due to the natural variability in medical outcomes. Yes. So the key insight in this our presentation is that from the overall modeling work, we identify several key insights. So we noticed that tumor size and cancer stage were strongest predictors of survival. Also, the decision tree models provided higher interpretability, making it easier to understand feature importance. And also, the logistic regression served as a strong baseline, but decision tree allowed us to capture nonlinear relationship in the data. So together, these models helped to reveal meaningful patterns in breast cancer outcomes. Next, so in conclusion, our project demonstrated that machine learning can play a valuable role in predicting breast cancer survival outcomes. With clean data, proper encoding, and careful model selection, we were able to generate both classification and regression predictions that align well with known clinical factors. So the model showed a promising performance and provided a clear insight into which most significantly affects patient survival. So we had our data from this link, and also with Python libraries, we use NumPy, we use Pandas, we use Seaborn, we use Scikit-learn. Thank you very much.